All right, we're on page 3 of the 7-2 notes. Really, the problems on this page are the first 3 anyway. There's one extra step we have to do if we're given 2 points rather than a slope and a point. All right, so if we're given this guy right here, 2 points, so we know a line goes through these 2 points, and we want to find an equation of a line. And regardless of the form we want to find, we're going to have to find the slope. Okay. But we know how to find the slope, right? We subtract the y's, subtract the x's, and we divide, right? So let's out in the margin here, let's find the slopes. And just to make our life easier for these future problems, let's find the slope of all 3 of these. So I'm going to do 4 minus 7, that's negative 3, right? Over 5 minus 3, which is 2. So slope's negative 3 halves for this guy. Here, let's find the slope. Negative 2 minus negative 1, so that's negative 2 plus 1, which is negative 1, right? And then 5 minus 2 is 3. And then let's do this one. Negative 3 minus negative 4, well, that's positive 1. And then negative 2 minus negative 1 is negative 1. So that slope is just negative 1. Alright, so we found the slopes of all 3 of those. Now we'll work on them one at a time. So we want to find an equation in standard form. Okay. Remember, to get to standard form, I'm going to go through really all 3 forms. And on MyLab, you may be asked to give slope-intercept form. And if you are, you can stop before you get to standard form. Okay. Just make sure you understand the difference between slope-intercept form and standard form. And make sure you pay attention to the directions on MyLab. If you're asked to give slope-intercept form, you can stop at that point and give slope-intercept form. If you're asked to give standard form, you got to go that one step further. All right. So again, remember, I'm going to write this down up here. The point-slope form. That is kind of the place to start. Rarely are you asked to give your answer in point-slope form, but it is very useful in working toward the other forms. So point-slope form, remember, is y minus y1 equals m times x minus x1. Now, something a little different than the last few examples is that we have 2 points, right? So which point do you want to be x1, y1? Well, the answer is it doesn't really matter. You could pick either point. You could either pick 3, 7 or 5, 4, whichever one you want. You'll end up with the exact same answer either in slope-intercept form or standard form, regardless of which point you pick. So I'm just going to go ahead and pick the first one. I'm going to call this one x1, y1. So point-slope form, we have y minus 7 equals our slope we found, negative 3 halves, times x minus 3. All right? So that's point-slope form. I'm going to work my way to slope-intercept form. I'm going to add 7, or I'm going to distribute and then add 7 to both sides. So distribute, we get negative 3 halves x plus 9 halves. And we have y minus 7. Again, if the fraction operations are not your favorite thing to do, you can use a calculator to help. So now I'm going to add 7 to both sides. I didn't leave a lot of room on these problems, so you might need another piece of paper. I'm going to try to squeeze it in to these spots, but we'll see if it works out. So I'm going to add 7 to both sides. That gives me y equals negative 3 halves x, and then 9 halves plus 7. Well, 7 is really 14 halves. 14 and 9 is, what, 23, right? So plus 23 halves. All right. So that is your slope-intercept form. So if you were asked to give the slope-intercept form, you would stop and enter this into your MyLab. If you're asked to give standard form, you got to go a little further, right? We got to get all our x's and y's on the same side. I'm going to add the 3 halves x. I'm not going to write that addition, but I'm going to add 3 halves x to both sides. That gives me this right here. And then we got to clear the fractions. Since this coefficient of x is positive, we can just multiply everything by 2. 2 is the only denominator there, so we multiply everything by 2. 2 times 3 halves, x is just 3x. 2 times y is just 2y. And 2 times 23 halves is 23. And that is our standard form, right? So we, again, went through point-slope, worked our way to slope-intercept, and then worked our way to standard. So let's try that with the next example. Again, this might be a great time for you to pause and try to do this one on your own. And then compare it to what I'm going to do right now. So, let's see. Found the slope already, right? So let's work on point-slope form. I'm going to use the first point. I'll make this my x1, this my y1. Again, either point will do, whichever one you want to use. So I'm going to say y minus negative 1 is y plus 1 equals our slope, m, negative 1/3, times the quantity, x minus x1, so x minus 2. Okay? So that is point-slope form. I'm going to distribute and then subtract 1 to get slope-intercept form. So if we distribute the negative 1/3, we get negative 1/3 x plus 2/3. Alright, and then I'm going to subtract 1. I'm trying to squeeze this in again. Subtract 1 for both sides. Do that up here. So then we have y equals negative 1/3 x and 2/3 minus 1. Well, let's see. 1 is really 3/3, right? So 2/3 minus 3/3 is a negative 1/3. Right, and you can check that with a calculator if you're not comfortable doing those fraction operations in your head. I've just had a lot of practice, probably more than you have. So, alright, so this is slope-intercept form. So we start with point-slope form, distribute, subtract the 1, we get slope-intercept form, and then we need to move all our x's and y's on one side. We add the 1/3 x, so 1/3 x plus y equals negative 1/3. And I'm going to multiply everything by 3, right? I don't need to multiply by negative 3 because this coefficient of x is already positive. So multiply both sides by 3. And 3 times 1/3 x is just x. 3 times y is 3y. And then 3 times negative 1/3 is a negative 1. So that is my standard form. Okay. Again, MyLab may ask you for a slope-intercept form sometimes. If that were the case, you would stop right here and say that's my answer. But if it asks for standard form, you got to go a little further. Alright, we have one more of these, and even less room, but I think this one is a little easier because your slope is not a fraction, so there'll be kind of less steps here. I'm going to use the first point again, so we'd have y minus negative 4 is y plus 4 equals our slope, negative 1 times the quantity, x minus negative 1, which is x plus 1. That is my point-slope form. To get slope-intercept, I'm going to distribute. So I'm going to do that over here. Distribute the negative 1, so we have y plus 4 equals negative x minus 1. I'm going to subtract the 4. So I get y is equal to negative x. Negative 1 minus 4 would be negative 5, right? So we have y equals negative x minus 5. That is your slope-intercept form. If we want to get the point-slope form, we're going to add x to both sides, right? Show that this time. And so we get x plus y equals negative 5. Now in this case, we have all integers. So we don't have to multiply by anything to clear any fractions because we don't have fractions. And also, the coefficient of x is positive. It's a positive 1. If it would have been negative, we still have to multiply by negative 1, but it is positive, so this would be our standard form. So that's about as hard as we'll get as far as finding equations of lines. If you're given 2 points, there are a lot of things you got to do. But if you follow this process and check your work, and if you make a mistake, go back and make sure you didn't get a minus sign wrong somewhere, or forget to multiply by a negative, or maybe your fraction operations you could check with the calculator. You should be okay. Now, we have a few more problems at the bottom, but they all kind of are special, and they're actually easier. They involve vertical and horizontal lines. So in general, a vertical line that goes through the point AB has an equation x equals the x-coordinate A. Okay. A horizontal line that goes through the point AB has the equation y equals the y-coordinate B. So if you know a line is vertical or horizontal, finding the equation is much easier. In fact, these equations are in standard form. We have all our x's and y's on one side. Of course, there's not a y with this one. There's not an x with this one. But all the x's and y's are on one side and the numbers on the other side. As long as the coefficient of x and y is positive, we're good. Alright, so let's use those two facts to help us with these problems. And you might say, well, how will they help us with these problems? These problems look exactly the same as the ones up here, right? We're given 2 points. We're asked to find an equation in standard form. But let's find the slopes just as we did before. So here, my slope here. Subtract the y's, 8 minus negative 7, that's 15, right? And negative 1 minus negative 1 is 0. Oh, wait, the slope is undefined because we're dividing by 0. Undefined. So what do we know about a slope that's undefined? Well, that belongs to a vertical line, right? Notice the x-coordinates are the same in both of these, right? Which means we're going to have a vertical line, okay? If it's a vertical line, the equation is simply x equals whatever the x-coordinate is. In this case, it's negative 1. So much easier. We didn't have to go through all that process because we recognized this was a vertical line. So let's look at this one. Slope. We take negative 6 minus 2, that's negative 8. Divide by 0 minus 0 is 0. Guess what? Slope's undefined again. Slope's undefined, that should tell you it's a vertical line. We have x equals the x-coordinate. X equals 0. So those are both vertical lines. I might even say that. This is vertical. And this one is also vertical. If you wanted to verify that they were vertical, you could plot these points, right? If you plot these points, you could see clearly it's a vertical line. All right, let's look at this one. Slope, let's see. Negative 5 minus negative 5. That's 0, right? Subtract the y's. 8 minus 4 is 4. 0 divided by 4, well, that's 0. Here, the slope is 0. It's not undefined, but it is 0. What does that tell you about the line? Well, it should tell you the line is horizontal. Horizontal line has an equation, y equals whatever the y-coordinate is. Notice the y-coordinate is the same in both these. It's negative 5. So y equals negative 5, which happens to be a horizontal line. We didn't have to go through all that process. You could go through that process, but it's not necessary if you recognize the slope is 0, giving us a horizontal line. So these problems on the surface may look just as hard as the ones up above, but if we have the knowledge of what the slope means as far as vertical or horizontal, these problems become much easier. If the slope is not 0 or undefined, though, we do have to go through this stuff right up here. Alright, so that's it for this page. I'm going to stop this video and we'll continue on the next page.